Hey guys, this is Mrs. Rooker, and this is day 2 of the matrix unit. Today we're going to be multiplying matrices. Go ahead and pause the video and try the review problem really quick, and then I will put the answer up in just a minute. Alright, the correct answer should be D. It says the company has a 40% off sale, which matrix is going to show the price after the discount. Well, if you're getting 40% off of something, what that means is you're actually paying 60% of the original price because it's 40% off. So what I would do is just multiply each number by 60% or by 0.6, and that should end up giving you matrix D. So when you are multiplying matrices, you have to make sure that your dimensions line up appropriate. So if we're multiplying an M by N matrix by an N by P matrix, the ends must be the same. Oops, that was my eraser. The ends must be the same, and the result is going to be an M by P matrix. So this and this must be the same, and then our resulting matrix is going to be whatever these outside numbers were. So since this is rows and columns, the columns in the first matrix must match the rows, the number of rows in the second matrix in order to be able to multiply them. All right, and when you multiply the corresponding elements in each row and column, then add the products. This is a graphic, this here, that kind of shows exactly what to multiply and where to put it. So you'll see here, this is our first row. We multiply all the numbers in the first row by all the numbers in this first column, and then we add them together, and that gives us our first element in our first row. Then what we're going to do next is we're going to multiply the first column, but this time we're multiplying it by our first column, and then second row, and then that's going to give us all the elements over here. Then after we've done that, we multiply our entire second row by our entire first column. That'll go here. And then lastly, we multiply our second row by our second column, and that goes here. Hopefully this will start to make more sense when we have an actual example. If the number of columns in the first matrix does not equal the number of rows in the second matrix, then you cannot multiply the matrices. Also, this is important. A times B does not equal B times A. Meaning, if you multiply one matrix by another, order does actually matter. A times B does not equal B times A. So that's, I believe, the commutative property with matrices does not exist, meaning order does actually matter when you multiply matrices, which is not the same with normal numbers. All right, so this is a 1 row by 3 column matrix, 1 row, 3 columns, and this is a 3 row by 1 column matrix. Since these two middle numbers are the same, we can multiply them. And our result is going to be a 1 by 1 matrix. So we're basically going to end up with a really tiny matrix, just 1 by 1. So to do this, we multiply all the numbers in this row by all the numbers in this column. So we start with 2 times -1, which is -2, Then we add that with 3 times 0, which is 0. And then we add that with 4 times 1, which is 4. -2 plus 0 plus 4 is going to be 2. So when we multiply those two matrices together, all we get is 2. Okay, moving on to number 2, if I can. There we go. All right, so this is a 1 row by 2 column, and this is a 2 row by 1 column. So since those are the same, we can multiply them, and the result will be a 1 by 1. So my result is just going to be a 1 by 1 matrix. All right, I multiply the first and the first. 4 times 7 is 28. And then I add that with the second two multiplied together. 9 times 3 is 27. 28 plus 27 is 55. My answer there. All right, next one. We've got a 2 by 2. That's multiplying with a 2 by 2. Since these match up, we can multiply them, and our result will be a 2 by 2 matrix. I think in order to show my work a little better, I'm going to do my work over here. All right, so I multiply this first row by this first column. 1 times 1, or -1, is -1, but then I need to add that with 4 times 2, which is 8. So that's going to be -1 plus 8 is going to be 7. Okay. Then I multiply this row by this column, and my answer is going to be over here. So 1 times 0 is 0, and 4 times 3 is 12. So 0 plus 12 is 12. Then I multiply this row by this column, and the answer will go right here. -2 times -1 is 2. 1 times 2 is another 2. 2 plus 2 gives me 4. All right, and then lastly, I multiply the second row by the second column. -2 times 0 is 0. 1 times 3 is 3. Add those together, and we get 3. So this right here will be our answer. Another 2 by 2 being multiplied by a 2 by 2, so our result will be a 2 by 2 again. So first row by first column. 2 times 4 is 8, plus -1 times 2 is -2. So the 8 minus 2 will give us 6. Then we'll do the first row by the second column. 2 times -1 is -2. And then -1 times -1 is +1. So -2 plus 1 is -1. And then second row by first column is going to be 0 times 4 is 0. 1 times 2 is 2. 0 plus 2 is 2. And then lastly, we have the last row times the last column. 0 times -1 is 0. 1 times 1 is 1. Add those together, and we get 1. I was just checking my work on this, and I noticed this row and this column over here that would give us this answer, I messed up. So 2 times -1 is -2, but then -1 times 1 would be -1. So this should be -2 minus 1, which would give us -3. Sorry about that. All right, moving on. So here, you want to be really careful. This is a 1 row by 2 column matrix, and this is a 2 row by 2 column matrix. So this can multiply. We can multiply those together, even though the dimensions look a little weird. They can multiply. Our answer is going to be a 1 row oops, 1 row by 2 column matrix. So it's this by this. So I'll put my work there and then my answer here. Alright, so we multiply this, our only row here, by this first column. 6 times 5 is 30, and then 5 times 2 is 10. So 30 plus 10 is going to be 40. And then we multiply this, our only row, by our other column. 6 times 1 is 6. Sorry, my pen stopped working. There we go. 6, and then 5 times negative 3 is negative 15. So 6 minus 15 will be negative 9. And that'll be our answer. Number 6. This is a 2-row by 1 column matrix that we want to multiply by a 2-row by 2 column matrix. Big issue. Those are not the same. Cannot do. Not possible. We can't multiply a 2 by 1 by a 2 by 2. If they were the other way around, if it was a 2 by 2 by a 2 by 1, then we could. But since these didn't line up, we couldn't. Alright, last one. This is a 2-row by 3 column that we're multiplying by a 3-row by 3 column. Those line up. Our answer is going to be a 2 by 3. I should probably leave a little more room because we're going to have a lot of things that we're adding together. So I'm going to give myself even more room there. Alright, so first row times first column. 1 times 1 is 1. 0 times negative 2 is 0. And then 2 times 0 is another 0. Add those together and my first item is going to be 1. Alright, then we multiply, we'll switch up the color a little bit, this first row by the second column. 1 times 3 is 3. 0 times 2 is 0. And 2 times 4 is 8. 3 plus 8 is 11. Okay. Then first row still, last column. 1 times 7 is 7. 0 times 6 is 0. 2 times 5 is 10. Add together, 7 plus 10 is 17. Alright, now let's move on to the next row times the first column. 0 times 1 is 0. 1 times negative 2 is negative 2. Negative 1 times 0 is 0. So that just gives us negative 2. Then we'll multiply that second row by the second column. 0 times 3 is 0. 1 times 2 is 2. And negative 1 times 4 is negative 4. 0 minus 4 is negative 2. Alright, last row and last column. So 0 times 7 is 0. 1 times 6 is 6. And negative 1 times 5 is negative 5. 6 minus 5 gives us 1. Alright, with all that work, there is a good chance I could have made a mistake. So if you look at question 8, it says check your answer number 7 by using the matrix menu in your calculator. So the first thing we do is we go to matrix and edit. We edit both matrices, and then we're going to use that option to help us multiply the two matrices. So it's actually pretty easy once you get kind of used to this. So the first thing we're going to do is we're going to go second, so shift, and then you'll see right above this x to the negative 1 power, you'll see matrix. So we go matrix, then we scroll over to edit, and then we have to put in the correct dimensions. So our first one was a 2 by 3, so we do 2 by 3. And then we enter all the numbers. So 1, 0, 2, and you just click enter in between each one. 0, 1, and then -1. Make sure you're using the negative button, not the minus button. Okay, and then we just quit. We just clear out, then you go back into matrix, so your second matrix again. Now we're going to go down to B and scroll over to edit. Oops, make sure you're highlighted B, so you're editing a new matrix. This one's going to be a 3 by 3. And then we enter, let's see, it's going to be 1, 3, 7, -2, 2, 6, 0, 4, 5. Okay. And then just click second and quit again. Now we go back to matrix and you click enter on A. So it'll just grab matrix A. Then we're going to do times because we're multiplying matrix A by matrix B. So you'll go back into the matrix, highlight B, click enter. Now click enter one more time and it'll multiply together matrix A times matrix B for us. And oh my goodness, we got it correct. I'm actually a little surprised. Good work. Usually I make a little mistake here and there. So yeah, make sure to ask your teacher in class if I went too fast on anything or if you're confused about anything, and have a great day. Thank you guys.